And we're back, and it's COMP305, Game Programming 1. It's the winter 2016 semester, week 3, lesson 3, part 4. And we're just at the end of our day. We have 20 minutes, and I want to talk about a little bit of collisions, right? First of all, what is a collision, right? Well, in order for me to illustrate this nicely, if you've never done any kind of game stuff before in your life, which you may not have, right? I'm going to bring up my favorite program, which I use, which is Fireworks. You could use different programs, but one of the ones I use for graphic manipulation is Fireworks, and it's Adobe. It's not free. As students, you have discounts, and they haven't updated Fireworks for a while. It's like a Photoshop Lite. Okay, let's go new, or I can open up a file. So I'm gonna go new, but I want to create my size of my screen, 640 by 480 here in Fireworks. This is a you watch and I do kind of session. Okay, so here's my screen as an example, and I want to load up my ocean in the background. So just to give you an example of what it looks like, I could do that, but what I really want to do is I want to open up my plane. So if I go back to desktop, and if I go to Unity projects, and if I want, I'll actually look at the project that I'm working on, which is COMP305 Winter 2016 Mail Pilot. Under Assets, under Sprites, I have my plane. So here's my plane sprite, and I'm gonna open that up. Yay! There's my plane. And what I'm going to do is I'm going to copy this plane, so copy it, and I'm going to go back into the screen here and paste it. There's my plane. There's my plane. So my plane is here, and I want to kind of create a collision between my plane and my island. All right, so let's open up my island. So open. Let's just bring the island to play here. So here's my island, and there it is. I'm going to copy my island. Again, I'm just doing this in a graphic program so you can see it, and paste. My island. So I want to do this. So when my plane comes to my island, notice how my island and my plane are kind of square, right? And if I zoom in, right, so you can see my island and my plane a little bit more clearly. This is where I want to demonstrate this. If my collider, if you think about my collider as the bounding box around my plane, this is one way to do collisions, by the way. I can say this. I can create a box around each object. Here's a box. There's the blue line. Look at the blue line around the island. And if this box intersects with this one, collision, right? That's all we do. So if we do this, so I'm going to ask you the question: is there a collision here? No, not really yet. It's just at the edge, right? How about now? Yes, right. And let me reorder them so they look right. All right. How about now? Is there a collision?
No. Yes. No. Yes.
This is the problem with box colliders, right? My plane is in a regular shape, and also notice how my shadow, right? The shadow of the plane also is taken into account because it's part of my sprite object. It's a nice effect, but it messes me up from a collision perspective. So the box that goes around my plane itself, this bounding box, if we use box colliders, right? It's a problem. Same thing over here. If I was to take this object, is there a collision here? No, but look how these collide. This is a non-visual collision, but it is a collision from a programming perspective, right? So we have a collider saying, yes, you're colliding, but there's no visual collision. That's a problem with games, right? So how do we do it? What about if we use different shapes? Like, for example, if I had two spheres, well, you run into the same problem, right? Let me show you this. So if I have some kind of circle, so let's use an ellipse, I'm going to draw it around the plane. Okay, so let's just draw the circle around the plane as best we can. Okay, so don't worry about what's in. Let's take the fill away. So we'll say no fill. That's there it is, no fill. And so here's the actual shape. And I just want to show you this so you can see. I'm trying to illustrate it for you so you see the problem, right? So here's the best case as an example as a circle, some kind of thing like this. Okay, let's make the border a little bit more pronounced so you can see what I'm talking about here. So we're going to make the border that's black. So there's a black border as an example. Let's make it a couple pixels wide, right? So you can see what I'm talking about. Okay, circle. Okay, and let's do the same thing. I'm going to copy this object, and I'm going to pull it across to my island because it's roughly the same size. And we're just going to make it so it's a little bit larger. We're just going to modify the actual shape of the object. So as we're drawing, we're going to make it so that this object, notice how my even though my island is physically smaller than my plane, believe it or not. It's only 62 by 63. It requires a bigger collider because to encompass the whole thing. So this is approximately right. Okay, now, if I was to combine these two, so I have this thing with, let's just put it, so this is my bitmap, and this is my plane. I want to kind of move this up here like this, just to layer it properly. And I want to combine these two things. So we're going to group these things together, right? So I can do that. I can say kind of take these two things here and, you know, both those things, and I want to group them. There we go, groups. And I want to take this thing here just to make it easy for us to see it. And I want to group those two things too. Yay, groups. So this is our, this is my plane, and here's my, in this program, my island, right? Okay, just to illustrate this. So now I have spheres, okay, or circles. Now, is there collision here? Yes. Is the plane colliding with this? No. What if I adjusted this? I mean, I could probably adjust this a little bit, make it smaller, but then I wouldn't hit the wingspan. And I can't use ovals. That's not possible, right, for planes, like, or for colliders. I can have a circle collider, no collision, but there's a collision, right? And I'm going to show you there's areas that you'll have a problem. Here it works okay, right? If I kind of put my, you know, here or whatever, and I have to kind of reorganize the way it's set. So here, you know, there's no collision, right? But we're showing a collision. Now this is happening so fast that some people may argue, and there's two camps. One camp says, who cares, right? It's happening so fast. If you have a collision like this, you're good. Yeah, I'm not of that camp, because, you know, you're going to probably collide here. And you're going to see like it pop away somehow, or something going to happen where you're going to hear a collision and you're playing the game. Imagine if you were playing the game, you're like, hey, I didn't hit that, but you hit it because my collider is so big, right? The bounding box, and I could shrink the colliding bounding box and all that stuff, but it's a problem. Okay, so that's one. Option two, you can use something called a mesh collider. A mesh collider is more computationally expensive, so more operationally expensive, right? And what the mesh collider does is it tries to wrap around the objects almost exactly, right? More accurate collisions, but more computationally expensive. And you'd have to do them for each object to be kind of thing, because these are all irregular objects, they're not squares. If I made a square colliding game, perfect, because then you see the square collides with another square, visually and programmatically, it's the same. Here, visually and programmatically, different. So how do I fix that? Well, some people, what they can do is they can use something called the distance formula. So we can take a distance, let's say, for example, I have a distance between this middle of my plane to the middle of my object here, right? And let's just color this a different color. So let's make this red, right? So here's my red distance. So I could say this: if the distance between my two objects is less than half the height of both my objects combined, right? Half the height. That's probably going to mean that it's something like this. Because if it's less than half the height, because both this distance is, I get half the height of my plane plus half the height of my island, which gives me you know, the collision distance. And if I test for something that's less than that, half the height of each object, collision, right? I could do that. But that means I have to test for the distance between my objects every frame. So that means when they're over here, I'm testing the distance. When I'm over here, I'm testing the distance. And they're far away from each other. I'm testing the distance. But I want you to know that, you know, if I'm using the collider method, it's doing the same thing, right? So you really have to kind of, I don't know, choose your poison, if you will, right? Both are expensive computationally. You got to decide what you want to do. For me, what I recommend us do when we do two-dimensional games like of this nature, not the ones that use physics. Your next assignment is going to use 2D physics, right? So you can actually do a platformer, so that you can do a physics simulation. That's not this. This is a 2D top-down, you know, kind of game that does kind of our scrolling, right? So I recommend the distance formula, because otherwise we're going to have this weird anomaly, right, like this. And the other way to do it is using, like I said, mesh colliders, which are really computationally expensive. So that means if I have, like, right now there's only like few objects, like plane, and there's a cloud or whatever. What if I have like 50 aliens, right, in the future? When you make your game might be different than mine. That means the more objects you add in, and they're each mesh colliders, unless they're square-shaped or round-shaped, right, they're going to be computationally expensive. That means it's going to slow down your game, especially on a device, like a mobile device, right? So this might make everything, even the playing field, no matter how big the device or how big your sprites, you're always computing the distance between the objects. Okay, So how do I do that? Nice idea, Tom, you might say, but how do you calculate the distance between the objects? Well, I need to create a way of detecting the collision, first of all, right? So again, way one, let's go back to Unity. And I'll show you how you can do this the first way, the cheap way. I prefer distance formula.
So,
yes.
what if we combine these two formulas?
I don't know. I don't recommend.
I mean, if we use the square collision, and if the square collision happens, it calculates the.
And see how you just did that? See how you combined? And that means you're going to have blah, 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 and something else. It means two. You're going to do double the computations.
What if it happens only when the collision happens?
If this happens, then you're checking, you're still checking, you're still checking every frame. Checking. If I'm checking, might as well, right? Remember, it's any computation you do, if you say if in a frame, that means you're checking 60 times every second, right? Same thing if you're checking collisions. Let's run in here and see what I'm talking about here. So here's my plane, like we talked, this is a real game now, right? And notice how I have the ability for me to add components to my plane. Here's one way to do it. So add component, right? And if you notice, I can go to Physics 2D. Let's do this with me, guys, right? Physics 2D. Under Physics 2D, notice how I have a bunch of different colliders, right? I have a box collider, a circle collider, of an edge collider, a polygon collider, right? Lots of stuff here, right? Polygon collider is what you need. This is kind of like a mesh collider or whatever, right? So if I click polygon collider, look what it does to the plane. Watch. Doop. Kind of, you know, draws this shape around the plane, and it even draws it around the cloud, the shadow, right? This is the cheap and dirty way to do it, right? Still computationally expensive. Either way, distance formula or this, computationally expensive. I prefer the distance formula, but it's more challenging to code. So let's write it this way first, and then I'll show you the distance formula method, okay? So this is wrong, right? It's inaccurate. So I want to click on this Edit Collider object right here, right? This Edit Collider button. Click onto it. And notice how now I have access to change the shape of my collider. This is new, I'll be honest with you, in the most recent versions of Unity. If you're using Unity 4, may not be able to do this. I'm going to pull this in as an example, so I can change the shape of my collider. So it has nothing to do with my cloud, my shadow, because I don't care about my shadow. My shadow has nothing, it's not real, right? I just want my collider to hug my plane as best as possible. And if you want to add additional points, right? Notice how I have a point here, and I want to have additional point. If I go in the middle between 2 points, I get another point if I hover over. Look, like this. And if I drag, I have another point now, so I can kind of make my collider as accurate as I want. Remember I said, the more points, the more computationally expensive this whole process becomes, right? So we don't want to add too many points. We want to make it as even as possible. And notice this is all being done by hand, right? So notice how I go between these 2 points. I click somewhere in between, and now I add another point automatically, right? And the same thing goes here. Kind of add another point, and I add another point. And you can see that as we keep doing this, it becomes a drawing exercise, right? Neat, you know, it is neat, and you can get pretty close. If you spend your time editing your collider, you can do that. Unity has a pretty good way of doing it for objects or shapes that are pretty uniform. But where shapes are not uniform like this, you're going to have to do a little bit of your own work. Right, so here we go. This is kind of close. Notice that there's still, I'm not quite satisfied with this, and you know, I'm just drawing the shape, so I'm kind of pulling it closer. Try it out. You can see that there's some certain techniques you can use to kind of make the shape as close to your the option as you want. There it is. Right, there we go. So that's pretty close. See, my shape looks like this, right? So I've kind of come as close to this as possible. Now I have a lot of points here. Lots and lots of points. Cool, there's my plane. There's my collider for my plane, and I'm almost perfect. There's some issues, you know, but it's not bad. Have you done the same thing? That's called a polygon collider, right? Now, if I did the same thing for, this is the great thing about Unity. Notice how I have my planes done, right? I'm going to save. And here in my, right here in my island, I'm going to click my island, and I do the same thing. I'm going to add a component, right? I'm going to go to Physics 2D, because we're playing 2D, right? And I'm going to go to, again, if I look at the type of collider that I want a polygon collider. And now look, it's pretty good. It's much better than the plane, right? Because it's you know, there's no shadow, you know, kind of stuff, I can probably pull it around so that's a little easier to make. And it just takes a little bit of practice. If you try this out a little bit, you can create your own collider shape the way you want it, right? So it's pretty accurate. Again, this is the cheap and dirty and expensive way to do it. There are better ways, right? And we're going to talk about the better ways later. Yes, you want to have a question? All right, so there's now I've got a polygon collider for this one. This is pretty good. Look at this one. That's not bad. It's not accurate, like it's not 100% accurate. And you see, I mean, I'm trying to hug the island as much as possible. If I want to make it really accurate, especially where I want to make it accurate is the bottom of the island. Why do I want to make it accurate on the bottom of the island and the top of the plane? How come? Because my islands come from the top, right? So the bottom of the plane and the top of the island, I want to make as accurate as possible, hugging that geometry as best as I can, right? So the top of my plane and the bottom of my island. And if I zoom in here, if I was to zoom in here to see what I'm talking about, I can zoom in and be as careful as I want. Look at what the editor allows me to do. Right? So again, I want to be as close here as I want to the bottom of my island, right? And again, I can add additional points of contact, right? So that there's not as many, you know, discrepancies here. Notice how I've got a bit of a discrepancy on this side, right? Not as many discrepancies here as there are on the top. I don't care so much about the top. The top can be, you know, better, closer, you know, or farther away than this, doesn't matter. You know, again, I'm just being really specific now. But as you can see, there's work to be done, right, to make this polygon collider work for you. I'm spending a lot of time ahead of time. We're doing our calculation. What this does, how does Unity store all this stuff? Anyway, there is a meta file that keeps track of the shape that we're defining, this new polygon shape, this unique polygon shape or custom shape we're defining. And all it's going to do, and I'm just making it as accurate as possible, you can see here, all it's going to do is keep track and say, hey, if one collider crosses the other one, right, kind of that thing, then we're good to go, right? And that's pretty good. I don't care about the top so much. This is not as accurate, but the bottom, you can see that there's a little bit more accuracy on the bottom of my island, and that's pretty good, right? Let's just fix up my plane one more time because I probably should have done a little bit better on the top. And again, if I zoom in, right, this is game creation 101, right? So that's why you have to understand this stuff. If you've never done it before, don't be upset with yourself if you're like, don't understand. Don't sit there and go like, don't get it. Why are we doing this? You'll see. That's all I can tell you. You have to kind of try and do what I'm doing, and you'll understand later as we get closer, you know, because you'll see that some of the colliders that we create are going to be way off. And you can see now that as I'm hugging my plane, right? It's like artwork, right? In some ways, you're kind of being artistic here, but you're actually, what you're doing is computationally, you're trying to be accurate. That's what you're trying to do. All right, there we go. There we go. There we go. There we go. And this is way off. My wing is way off, right? It's way over here. So I kind of was, by eye, I mean, you can only be as accurate as you want, right? But then eventually you're going to come to a point where you're going to go, okay, that's enough, right? Because, you know, that's good enough, right? And then, because remember, this is happening so fast, I got to go back to the other camp, that's talking to me in my head. Tom, it's not really that urgent. You know, you don't have to make it perfect because it's so fast that you're not going to see a big difference between the collision of the plane, right? And the more points I add, the more computationally expensive it is. That's pretty accurate. Okay, cool. We got that. Oh man, what about my cloud? My cloud's not on the scene. Can I add a collider to the cloud? I could. Let's do it. So add a component, add physics 2D, add well, I can't make the cloud needs it more than anything, right? So if I add a polygon collider here, cool, but yeah, I can't edit it. How come? Because it's a prefab. So in order for me to edit it temporarily, what I need to do is bring the prefab into the scene, right? Now notice there's some buttons here for the prefab. Because it's a prefab, once I'm done editing the collider, I need to click apply. And it applies it to all the other objects that inherit from this prefab. Cool, let's do it. So click edit collider. Notice as I go in, it's pretty good. Like the one that Unity gives you is pretty darn good, eh? Take a look. It's like really good. Actually, this is the best one we've got so far from this one. Now remember, the bottom one, I want to be as accurate with the bottom part of the cloud as I can because, you know what? If I'm not accurate, this is where we're going to get some discrepancies. The more accurate I am with the cloud, you know, as an example, we're using mesh colliders for each one of these things, or polygon colliders equivalent. The more accurate I am with the cloud, the more it's going to make sense for us when we collide with the plane. Because the cloud is going to kill the plane, right? So we want to kind of, especially here, because this is where the players will get really mad, right? If the collider looks a lot different than, you know, no visual collision, but you get a collision, that's bad, right? Because the player will say, man, that game sucks, right? Because it doesn't, I mean, I always die for no reason, right? That's what happens, because people don't know, right? They don't know why they're dying, right? They just know that, well, I'm dying and I didn't really hit. It's a glitch, right? It's not a glitch because someone programmed the collider to be really far away, or the method they're using for collisions is off, or it could be a glitch, right? But, you know, typically it's not. It's usually something else. Do you guys understand what I'm saying, right? So this is another question that I'm going to ask you on your famous test, you know, next week. I'm going to ask you questions around this stuff because, hey, what the hell? You know, I'm going to ask you about collisions and visual collisions compared to collisions that are non-visual in nature, programmatic collisions, right? Okay, cool. I think I'm pretty satisfied with this. Is pretty hugging the cloud, pretty good. You know, you can't see it. And now I got to click apply because it's a prefab. So it's going to apply it back to the prefab. Click, good. Now I can get rid of it. All right, so there's my prefab. If I pull it in now, and if I click this, you can see that it retained all my changes, right? So again, I can delete it. Cool. All right, so I've got my collision, and we're pretty much done for the day, yeah?
If you click apply, so is it for that particular instance?
No. When you click apply on an instance of the prefab, it affects every other instance.
What happens if I don't click apply?
It will be lost. Your changes will be gone.
Even for that particular instance?
No. Well, yeah, for that instance, it'll work for that instance, but none of the other ones. So so that's what I'm saying. It's important. If you want all the changes to be applied to all the instances of your prefab, you have to click apply so that it cascades down to all of them. Okay, cool. So we've got our collider, right? And we added colliders to all of our prefabs, but we're not done yet. This is just prep work. And next day when we get together, we need to actually programmatically detect when we're having a collision. We'll talk about that. Here's something you have to think about too, right? When I run my game, does it affect the game as is? I've added a new component to each of my objects. So if I press play now, what does it do? Well, it doesn't do anything right now because there is no, you know, no physical thing going on. Even though there's collisions, right, as an example, we want to be able to detect the collision between two 2D objects, right? Now, I'll tell you, sometimes you need one more component that we haven't talked about called the rigid body 2D. Even though there's no physical collision, we want to create a trigger collision where two collisions trigger a collision between the two of them. Not a physical collision. There's no physical collision here because they're passing over each other. So if I collide with something, I'm actually triggering the collision, which means, just one more thing before we end for the day. If I click on plane, take a look at plane. And if I look at my collision, my polygon collider, notice that there's an option that says is trigger. I need to click that. All right? Same thing with my island, is trigger. Same thing with my, oh man. Can I click it? Yes, I can. I'm okay doing that, right? Now I want to save everything. Why? Because I can use a special event handler that's built into Unity called onTriggerEnter2D, right? So when that collision, when that event listener fires or triggers, right? When that I can create, something's happening right now, right? Where I have these two things happen. When I collide with one object with another, I have to check, where am I going to check the collision? Am I going to check it with the plane, with every other object, or do I want to check each object with the plane? So do I want to put the collision detection on the cloud and the island, or do I want to put the collision detection on the plane object? That's the trick you have to think about. And if that's true, right? If we're doing the collision with the plane, we have to kind of do one of these. Or do I want my game controller to work out all the collisions for all the other objects, and they have nothing to do with the objects themselves? There's some questions. There's just design decisions here. And what's the best thing to do? These are the things. Now, when you do your tutorial, it's going to tell you to do things with 3D and converting it to 2D. That's what the tutorial does. So what they do is they use they use trigger colliders, but they use trigger colliders, 3D trigger colliders, not 2D trigger colliders, right? And they also use a rigid body 3D, a rigid body. Notice that if I go add component, any one of these, so my plane add component, notice that if I go to physics, I can go to physics or physics 2D. Physics applies to 3D objects, and physics 2D objects then is only for 2D objects, right? So we're going to talk about can I detect the collision? First, I want to detect it, and then what am I going to do with it? Because without collisions, we don't have any gameplay. We don't have the plane dying. We don't have points being generated. All right, so that's what we're going to do. We're going to talk about when we get back together Monday. All right, but for you for Monday, what I want you to study is the stuff we've talked about up to is it Monday? Tuesday. Sorry, Tuesday. Tuesday, I'll be all right. Tuesday when we get together, we'll be talking about this, and Wednesday we'll fix it up, and then by Friday your full game will be due. All right. We also haven't talked about sound, because each thing's got to make a sound when it collides. All those things have to be done. Everything is done through the collider. All right.